And thank you, audience, for being here and spending your valuable time with me for the next 45 minutes. This is a new presentation, so bear with me. Please give me a sign if I need to, stop for questions, or if I need to speed up, or, I really want this to be valuable time for you. So feel free to jump in with comments along the way. As Steve mentioned, I'm here to talk about a little bit more practical around how organizations use Hadoop. It's the most frequent question I get. It's like, okay, I know kind of what Hadoop is. I know it's a distributed processing framework and storage solution. But what do organizations actually do with it? I don't know if I need Hadoop. When should I deploy Hadoop, and what does it actually do for me? So those are the types of questions I'm going to try to focus on. And then, of course, I'm going to stick around afterwards if you want more, detailed information or more questions. I'm happy to take that discussion afterwards. How many of you know Hadoop? Oh. So my super quick overview might actually not be that super quick then. So I'm going to then walk through what Hadoop is and take it a little bit more time here, which means I might have to cut out some slides at the end, which is fine. I'll leave them behind. So Hadoop is, as I said, a distributed platform for data processing. That's the easiest way to describe what Hadoop is. And it's aiming those difficult problems that have become more and more frequent these days around big data, right? There's a larger volume of data coming in. There's many different types of data that suddenly might not match your current data models or structured databases. How do you put, in Twitter feeds into your SQL-like data infrastructure and make questions across data sets? It's not really a cost-efficient way to put it in traditional systems, because the flow of data is so rich, the variety of data types is expanding what we can handle with traditional systems, and the speed of data being generated is exponentially growing. So this is the big data problem space where Hadoop came around as a very interesting technology that's grown into the most popular technology to solve those problems. So Hadoop is actually consists of two components, MapReduce and HDFS, Hadoop Distributed File System. So HDFS you can think of as the distributed file system, the storage layer. I'm going to switch back and forth so you actually get a notion of all these components. MapReduce is a Java-based framework that you can implement your own algorithms or workloads. What you want to do to your data, how you want to process it, what you want to extract, what rows in this file are of interest to you, and what you actually want to do with it. Do you want to count the number of occurrences? Do you want to, aggregate, apply some logic to this data? Well, once you find it, that's the problem that MapReduce solves. So the mappers are finding your data in your data set that you have stored in HDFS in a distributed fashion, and the reducers are actually doing the logic, aggregating, reducing that data set to the answer you were looking for. I'm keeping it very high level still. So MapReduce is the distributed parallel processing framework. It's written in Java, but you can actually integrate with C++, other programming languages in many different ways. MapReduce is extendable through connectors or through API integrations. But you actually have to code your MapReduce workload yourself, which limits the usability to perhaps only the programmers, which is why in the ecosystem other kind of tools popped up to make that data accessible in more traditional ways. So if you look at Hive and Pig up here, those were kind of the next projects to pop up in the Hadoop ecosystem. Hive is basically translating your SQL queries to MapReduce workloads. So from a standard traditional SQL select star from blah, 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 where this and this matches, right? It actually creates Java processes, sends it off to the distributed file system where the data resides in little blocks across many, many machines, and process that data in its place, returns the value through Hive to where your query resided from the client side. And Hive is integrated with both ODBC and JDBC connectors, so it kind of starts looking like, oh, now I'm a BDA or a BI person coming from an SQL background, I can actually integrate and work with Hadoop. And Pig came around as a very simple, query language, SQL-like, but not the sequence process one. It's more process-oriented. So if you're a programmer slightly walking into the SQL and BI and data analysis space, Pig has been, become the most popular tool, query tool, or query language for programmers moving into data analysis. While Hive is more addressing the BI, business intelligence side, and the DBA users moving towards Hadoop and programming. So it's basically serving the same purpose of simplifying query on your data, but it's slightly different architected to suit these two different user groups. Make sense? Mm-hmm. Okay. Further, of course, Hadoop came with a promise of more advanced analytics, because you actually have access to all the raw data in there. Data, as it is generated, is stored exactly as is in HDFS. Why? Because you don't want to leave anything on the table. The promise of big data is if you store the raw data, you can later decide what to query. Versus in the traditional world, you have to apply a structure to your data, scale it down, maybe lose some information because you have to fit it into your data model. You actually form your data for your question in the traditional world, while in Hadoop land, you don't have to decide what to ask until query time, and that's when you apply your structure onto your data at that point in time. There is no data model. Okay? With me so far?
Yep.
Cool. So, advanced analytics, back to that. Advanced analytics is the promise of this, okay, what can I do with this new kind of data that I can store suddenly? And this opens the door and interest extremely in the machine learning country. So there's a lot of machine learning research from many, many years ago that now have entered the Hadoop land and formed into, implementing those algorithms, be it, recommendation engines, clustering algorithms, categorization algorithms, in a parallel fashion using MapReduce. Remember, MapReduce was the Java framework that you can implement your algorithm in. So think about machine learning algorithms and how the startup land and research land is now booming of all these scientists thinking about, okay, what if we now, with enough data, actually can make sense with machine learning? Machine learning has struggled, by the way, for a long time. Like, okay, it works for small sets, but once you expand, maybe the models doesn't really follow. What if you can train a model on a petabyte of data? How sure can you be that it works? Well, more sure than if you only had a few terabytes, right? So this is like the booming interest. I see a lot of startups in Silicon Valley around how to do statistical algorithms and machine learning algorithms implemented either through MapReduce or natively through some other workload on Hadoop. That's happening. So machine learning, that's the Mahout project. That's part of the ecosystem, but I bet you there's more to come. We have lately seen a need for more near real-time workloads. In the traditional world of Hadoop, Hive, Pig, Mahout, and MapReduce are all batch-oriented, meaning you have to kick off a JVM for each MapReduce process, And imagine you have like thousands of MapReduce processes running in parallel because you can. That's what enables linear scale of processing over terabytes of data. Now, that is not all your use cases that you need to apply to that data that you've stored in this platform. You actually have some near real-time use cases as well. For instance, business analysis, sitting behind his, I don't know, ClickView user interface or Tableau or MicroStrategy, you know, some BI tool. If you ask a query across your tables in a database, the response times is what? Less than a second, a few seconds, I don't know, depending on your query. But that's limited data, right? Maybe it's minutes if it's a really complex query. Now, if you kick off the same query on MapReduce through Hive or Peg, it's going to take some time. It's like comparing a Ferrari to a bus, right? Ferrari, you can have a few people in it, but it goes really fast. With Hadoop, you can have lots and lots of people in it, but it takes some time. But it's more powerful. You can transport more, you can get more people to where they need to be. I don't know if that analogy made sense, but you're going to hear more funny analogies, by the way. Keep on making them up. So the near real-time needs created these new integrations, or new projects even. If you look at Impala, for instance, that was an initiative actually by the company I work for, Cloudera, but that doesn't matter, it's still open source and anyone can participate. So Impala is a real-time query engine. It actually isn't based on MapReduce. That's the whole key here, along with some other interesting low-level optimizations like relying on the LLVM package and all that. But Impala processes SQL queries directly on the distributed file blocks that you have across many, many servers in your Hadoop cluster. So it doesn't kick off JVMs, it doesn't use Java, which speeds up a lot when you have tons and tons of processes to kick off, right? So Impala is a very interesting native query engine on your distributed file system. All right? Solar. Wait, is Solar part of Hadoop ecosystem now? Yeah, it is. Lately, the Solar, I don't know, how many know about Solar? Anyway, more people, great. So Solar is a very well-known open source search engine. So it's built on Lucene, it's the kind of the web service built around Lucene, which is the most adopted indexing engine out there. So recently, Solar integrated with Zookeeper. By the way, it's up there. It's kind of unknown to some people, but it's more, I don't know how to define it in a simple English word, but it's about process management or failover. If you have multiple servers running on your cluster and you want, a safe failover, if one process goes down, someone needs to be the brain keeping track of that process is down. Let's make someone else the master, or let's spin up another server to kind of fix that and have your services going. If the entity that keeps track of where all the file blocks resides, if that goes down, someone needs to be aware of that, right? So it's a process management. It's the one who keeps track of failover of processes, and also keeps track of configuration files. If a new server spins up, what am I supposed to do and where do I belong? That kind of information. Contact Zookeeper. That guy knows it all. The Zookeeper is kind of the brain. That's how simple I can explain it. So Solar community moved into integrating with Zookeeper suddenly to enable a more robust and scalable search solution. Now, hey, wait a minute. Integrated with Zookeeper, that means Solar is kind of stepping in a little bit, touching on the Hadoop community. So I put it in here because recently we also integrated Solar to run natively on HDFS, reading and writing indexes to this distributed file system. Hey, maybe solving that scale issue of index storage. all these things are moving the same way, which is basically bring the workload to your data instead of the other way around. Because moving data around is costly when it grows in size. Make sense? I'm going to cut this short. I have so much to talk about. So Q is a really good tool if you want to play with Hadoop and realize what all the backends are about. And I recommend you to download and play with, maybe you can play with our pre-built VM and explore these different components through Q. Q is the graphical user interface that you can kind of make sense of what it's all about. HBase is quickly said, it's a key value store. It's a different way of storing your data if you have use cases demand quick lookup for a specific ID. And it's also column oriented. This is excellent storage for click streams, for instance. For a specific user ID or IP address or what have you, you save all the clicks on your website for that ID. And this allows you to track how users actually walk through your website. That's a lot of data to store, by the way, if you have a lot of traffic. But it's a very common use case for HBase because it's based on HDFS underneath. So you can basically just store that data very cost efficiently and linearly scalable storage, right? But since the use case of exploring, okay, what do my users do on my web page, requires that key lookup. I want to, okay, for all these IDs from, I don't know, from Denmark, I want to see how Danes utilize my travel website, for instance. This is the quick storage solution for lookup of information that you want to process for a specific set of IDs or for a specific ID alone. So it's different than HDFS, where you can just store pretty much anything. It's a different model. So any questions on Hadoop? I might not answer them now, but we can save them for the question part. But since it's hot in your cache memory right now, I want to stop and collect some questions. Or you can type them in on your app if you only speak Danish. Okay, dead silence. I don't know if that's a good thing. You're stunned with information. Okay, great. So now to the real topic. I was here to talk about how people use Hadoop. Well, I'm going to start very high up again. There are two views in my mind. This is my 2 cents and me sharing my experience, right? So there are 2 steps or 2 views of big data problems in organizations today. One is, again, the scale problem, right? I have this data processing management system in my environment today, but I see or I predict a great growth, and I can't really afford scaling up the traditional systems. Or I have so complex queries that as my data has grown, they take longer and longer time to execute because the queries or the model isn't scalable, right? So it's a scale problem for some companies. And this is, by the way, often where companies start. But there are other drivers for Hadoop as well. I will get to them. But if there's like a future growth problem, like you're worried about tomorrow's scale, and you can't really figure out how to fit in the workloads in your traditional systems, that's a good point to go and look at Hadoop. Believe me, most large companies have. And the other driver is more about combining data sets. I have, my account info in Salesforce. I have some customer surveys in a database somewhere or in a file document storage. I have log files, from these customers. I have support tickets in some other system. But, you can only ask questions to that silo, or you have to struggle with some aggregation application on top, and you don't really, you have to do all the work, right? Here's where I find it more interesting. I mean, this is interesting too, but it's pretty straightforward. It's more about, I want to do to my data what I do today, more of it. It's not really new. The technology is new. It helps your pain point. But for an engineer like myself, it's like, it's not that innovation, machine learning promise, right? So this is where my heart burns and why I work with Hadoop. It's like, okay, there is no box. What else can you do? People talk about, okay, here's the box, it's the structured data, right? Analogy, again. Think outside the box, but in Hadoop land, there is no box. People haven't come up yet with what you can do. Everything hasn't been invented here yet. This is the new part, at least to me. Like, can I actually get some kind of 360 view of my customer by combining their free text survey data, their support tickets, their account data? Do I actually get happier customers if they are trained and had some consultancy services? Is that really true? Or what is the factor that makes a happy customer? Because what they write in free text is never enough because they don't spend enough time, or they are like having a bad day, or what can data tell me that can help improve my business? Or, I don't know, you tell me, what would you be able to do if you can ask questions across all your data? That's the interesting question. So breaking silos. Some typical use cases. So the most common one that, we have many Fortune 500 companies running in production today is to look at your infrastructure, realizing your data warehouses are great, but you can't scale with the load that's coming. And often there's a fixed time window involved when they really, okay, let's go into Hadoop land. It's kind of scary because we don't really know it, and it's still, although it's been around for many years, 5+ years, it's still like, okay, but it's open source, it's kind of evolving, we don't really know. There's a threshold there in perception of, should we really go into Hadoop land or not? But when you realize that your fixed time window of having that data processed in time for some customer SLAs, most customers realize they have to look at Hadoop. This is the only, I don't know, only way. Of course, you can spend lots and lots of money on, enterprise data warehouses, but most companies don't want that anymore when there is an alternative. So, the side-related use case here is, of course, those complex queries. If your data grows that you need to execute the query over, the query response time grows as well. And some companies that I've talked to have actually stopped some of their queries because it's not a reasonable response time anymore. And does it sound good to you when you stop getting business insight because of your infrastructure not being able to support it? That's like you're losing money right there, at least in my opinion. You can argue, but you all have the right to my opinion, by the way. All right, here's a real world example. Now I'm moving away from my opinion and sticking with data, which is what I'm kind of here to present. Data is true. It's the truth. Anyway, so one example, a network and storage company. They had a very interesting proactive support process of collecting all their devices and components, hardware components, log files in a phone home kind of mechanism. And analyzing these files to predict when they should send out a replacement component to their customers in time for when that component is actually failing, so they could reduce their customers' downtime. So this is kind of a proactive support use case. Did I explain that clearly? Okay, good. So they had about 600,000 phone home logs to process every week. And they had a constraint of 40% of those log files to have to be completed within an 18-hour window during the weekend to meet their SLAs. Now, this was a very good company. They had a lot of happy customers, thanks to this process maybe. And their customer size grew. That's a good thing. You want that to happen. However, that also came with a 7 terabytes a month data size growth of these log files. And they were already hitting their time window constraint. They couldn't process 40% of that incoming data load within 18 hours. That's the fixed window I talked about. This is where the pain comes. How do I scale out the processing to keep that window? And they also had some of those complex query limitations that I talked about. When they moved to Hadoop in production, they did find that they could definitely meet 7 terabytes a month growth rate. And they also, preempted the cost of having to grow even further with their traditional infrastructure. It's more cost efficient to just throw more nodes at a Hadoop cluster than go and buy some proprietary solution that is stale and limited in its flexibility, right? And they could also suddenly do those complex queries. They could ask questions they hadn't asked before. Questions that touched over 240 billion records per query. That wasn't possible in their previous system because it wasn't a realistic response time. No one would sit there for months to get the response. So they went from response time of the most complex queries that they still ran, from weeks of response time to hours. That's a measurable improvement. And they could suddenly ask for, new patterns for debugging and helping the actual quality of the components. So there's not only, the point I'm trying to make here, there's not only one win with Hadoop. Once you go Hadoop, you get to do other things with your data. It's only 10 minutes left. Shit. Sorry. This is just one use case. Okay, so a little bit architecture to wrap that use case up. And I have 5 more use cases. This is sad. I should get 2 hours. Or talk faster. I don't know. So here's a very common deployment today. You have your enterprise data warehouse or databases or traditional backends. You use Scoop, which we didn't talk about earlier, but it's the connector that is able to talk to structured backends, transport your data into HDFS and keep the structure. So you actually know columns and rows and all that on your data if you want to. You can use Scoop for that. So you use Scoop to get your data into HDFS. They do MapReduce processing to do some cleansing or aggregation of data. It's ETL. I want to prepare my data a certain way for this kind of query. Or the next week, I want to prepare it differently for my query. It doesn't matter. You can always change your mind, but it's more flexible in Hadoop land. So they use MapReduce to do some aggregation across a couple of databases or backends. And then they deployed Hive because that was, the simplest path forward. They already knew a little bit about MapReduce, and they could do some test queries through their traditional BI tools. Pretty quickly, they got tired of Hive response times and deployed Impala. So they got seconds response times or minutes response times instead of, hours. And then many companies also, as it's part of the data processing pipeline, they have 18 hours time window to process all these logs coming in, right? But then they also want to do something else with those logs. They want to do, log processing in some other form. So yes, you can do that in Hadoop, but many companies don't do everything at once. They start somewhere, they bring a workload, well-defined workload, onto Hadoop, and then they see that in success. It means that they might bring out those prepared pieces of data to their traditional systems again, using Scoop, and then you can serve to your regular reports. You don't have to change everything at once. But what happens often, as people do move to Hadoop, is those other things I said. It opens their eyes, they can do more things. So they move another workload onto Hadoop and realize, oh, this worked out quite well as well. And then the word spreads to other teams within their organization. They want to use Hadoop. And suddenly it becomes this Hadoop serving function in the company. And that's where interesting things happen, because then suddenly two teams within the same organization start sharing data. And you can, from there, go to my favorite use case of what new can you actually do? What new insights? Anyhow, I'm not going to be able to cover the other ones. The quick intro took away some time, remember? But I do have a log processing use case. Lots and lots of logs, many types. Enterprises today don't really have the capability of collecting everything they could. And just to mention, highlight there, one company I know took these ops logs, correlated it with marketing campaigns, and realized for the dev-focused marketing campaigns was actually the reason that a few days later their web services went down because the traffic was suddenly peaking. So for every dev marketing campaign forward, they did an expansion of cluster for their web services plan so that they could keep their SLAs to the new traffic that they actually wanted to capture from those events. So correlating data across organizations, that's an excellent example of what value that brings. I also had some financial services firm, fraud detection. It's a very, very common use case on Hadoop. Being able to realize anomalies out of lots of data is easier than if you only have or only can afford 3 months of data. So anomaly detection, outlier detection, whatever data you have, you want to see where it doesn't fit the pattern. Now we're touching on that machine learning again. Event prediction, pattern extraction, categorization, clustering. To the human eye, or based on too little information being available in your traditional systems, you can't really detect these. And we have many financial services companies, telcos, online retailers deploying fraud detection. This outlier, they already have those pattern algorithms from before, but applied to less data. Now they have re-implemented them in MapReduce, parallel way of processing more data. And thereby they can, obtain this harder to find anomalies and keep their brand as a safe, trusted brand. But the details are in the slides here, so you can read them afterwards. In this case, they also use Flume. Flume is the, streaming data ingest framework. It's a traditional pub/sub architecture. It comes out of the box with a gazillion sources that consume different streaming data, Log4j, Twitter API, what have you. And you can configure Flume to stream those events and filter, route any way you want on the data's way into Hadoop. And from Flume, you can also directly write to Solr if you want it indexed on its way in. You can write the data to either HBase or HDFS. It's a very flexible framework, very scalable. All to handle the terabytes, a couple of terabytes a day log generation. And customers who say they don't have that today, it might be because they don't collect them today. But again, I would want to collect data because that's where the value is, right? Another, I talked about HBase, writing to HBase as well. How much time? Am I out of time? Oh, really? Then I get extra time. All right. I will stand right outside the door and take questions. So the 360 view, I actually talked about in the beginning. You have market data, account data, finding the customer. Now switch customer recipe, like customer success recipe, for patient success recipe. Medical data. Like, can we draw? Yeah, there are tons of it, by the way. Can we draw any conclusion of, treatment A applied some time window before treatment B for a patient with a random set of, categories or definitions? Can we allow doctors to actually provide a better and accurate treatment, a more personalized? This is not only used for personalized marketing. You can use personalized for many different processes. And there's a lot happening in medical industry today. How can you optimize to do less error? Hadoop, if there's one thing Hadoop is good at, that I've seen production deployments on over and over again, it's collecting data, make new insights to improve a human interacted process. Be it, how should I distribute my movies to different regions in the US, for instance, based on their preferences as Saturday night. You can do analysis of the patient data or customer data. How can I distribute my merchandise in a better way to accommodate the customer regions that I've actually had a chance to analyze with more data available? Be it not only Twitter feed, but if you can combine these data sets, you get a better insight in who you're dealing with. And that's the vision. Okay? So one global online retailer, they had 22 subdivisions, different retailer brands. They had thousands of different products. They had online store, and they have real stores. You want to understand if a customer that goes online and looks something up actually goes to a real store and purchases it later. You want to combine that data. And for each subdivision, they basically had a lot of repetitive processes. They did the same processing in Netezza or be it Teradata, they had both. All over the place, they had the same processing across parts of the data. And they actually made a Hadoop strategy decision to replace a lot of that into one data repository on Hadoop, reduce a lot of overhead processing workloads that were done by each department. They could optimize the data warehousing environment. And guess what? They could do better marketing, better customer support, and instead of waiting 4 weeks to access some of those data sources to find these business improvements that were blocking other teams to do their job, every team could get the data immediately when they needed it. There was a lot of time saving, and that is a big dollar for that company, right? So I wish I had more time to talk. Yeah, as you see, there's a lot of interesting use cases that I won't even go deeper into today. But here we're touching on that land of excitedness that I'm really keen on learning more about. But I can point you to more use cases if you're interested reading up. So what to consider, I'm going to take 1 minute for this. The key benefits of moving to Hadoop is, of course, linear scale without the extreme price tag. Lots of flexibility. You don't have to decide upfront what to do with your data. You can change your mind later because you don't apply the structure to your data until you want to ask something. It's not saved with your data. You can combine and analyze different silo data in a way that isn't possible or costly, or you have to do a lot of work to do it today. It opens the door to expand business with new questions. Okay? But before you go there, now I promised you, gold and shiny castles, right? What I've seen with all these companies, if you don't have a valid business-driven use case, like you actually have a goal of, keeping that 18-hour window, and you're about to break it, or the company is not with you on what you can gain out of doing this investment into Hadoop, you're very likely to fail. Because Hadoop is an investment, perhaps to a cheaper price tag, but what I'm talking about here is there's a lot of learning still. It's not the pre-packaged plug and play, it's getting there. But this is what did you see, like 13, 15 different components that need to be weaved together. And yes, Cloudera does that out of the box for you, but that was my only product pitch. And makes it easier with management and everything, but it's still a learning curve. Every customer I talk to, it's like from the first realization that this might be what actually solves their current issues, business driven, there's a 6 months, you have to invest people, training, management infrastructure. You could, purchase that from Cloudera, but, it's how do you integrate with the rest of your environment? How do you actually, going to support this in your organization and outside? And last point, then I'm going to stop talking. Finally. Security, PCI compliance, production visibility, HA, disaster recovery. How do you going to manage that? Because, there are solutions, but it's still emerging. So you have to know a lot before you go into production on this. And there aren't all use cases who are fitted on Hadoop. Like, I often get the question around, what about OLTP? Is Hadoop ready for the real, like all the use cases on an enterprise data warehouse? And no, not yet. Right now, I would say, this is what most people do. You take some workload, ETL, be the most simple, most straightforward, and business motivated one for someone who isn't aware of all the other goodnesses. This is the number one use case people start with because it actually turns out very successful. Then when you have everybody's attention, you expand to other use cases. And then you can think of, do I actually have to move out the data? Or can I serve some other team in my organization on this? Can I get another team? That increases your value of your Hadoop investment. Once you expand the footprint, it's easy from there. And then you get to grow your team, train people, and increase your Hadoop knowledge within the company. I'm going to leave you with a quiz. I'm going to just skip through this. I have so many interesting things to say. Anyway. So, you learned a little bit about how organizations use Hadoop today, I hope. Was it good?
Very. Yeah.
Vote, please. Here's where you can learn more. The slides will be at your convenience through the GOTO conference. Quiz. How many believe that the technology is the real big data challenge? Good. Okay. How many believe that the knowledge is the real data challenge? Okay, a couple people.
What do you mean knowledge?
Like, can I access information about this technology somewhere? Is it, is the experience of this knowledge, of this technology shared?
Knowledge about the technology?
Yeah. Knowledge about the technology. Okay. So there are a few hands. I would say yes. That's about, a little bit the challenge. How many think is the lack of people actually experienced? Okay, you all got home with a golden star today. Yes, so it's very hard to find data scientists or experienced people on Hadoop, which is, you know, one of the key reasons I love this conference, GOTO, because I can be here, I can share my happiness about this technology and excitement, and I can encourage people to get into it, because there will be a need forward, trust me, you know.